Hello, so we're back with another work. I've received this in a bag. That's everything I have. It's a 14 Pro board and it came in for a data recovery. This is how it looks now. The board has been split by somebody, I don't know who. Right off the bat I can see a lot of broken pads here from the core board. And with my own tiny little eyes I can't see anything wrong. At least I can't see any cracks on the CPU. I can see that the board is bent here. That is really weird. Also I can see some markings of like something that appears as mask. UV mask. It's something greenish here on the sides. I can also see that this bottom board is bent also from this position, so if it was like this, it had a screw. I think the board was flexed like this, and I can see the interposer is really bent here, and I think there's broken pads also below the interposer. But this is a data recovery, and the customer also wants, if possible, to have a working phone after the recovery of the photos on the phone. In theory, for data recovery, we need, for 14 Pro, we need both boards. It's not important if the bottom is not the original one. We can use any good working bottom board, because if the boards are not soldered together or in an eye socket, then the top board will reboot every 3 minutes. So there's that. We will need charging flex for it, we need the power button flex for it, and we also need the proximity flex. So this is heavily bent. See how it looks like that? Okay, let's have first a look under the microscope and see how it looks. Let me bring you closer. Right. I don't see any cracks in the CPU, which is a good sign. I can't see any cracks in the PMIC, but we don't care about it too much. There's also no cracks, no apparent cracks on the NAND. And for this to be a working phone, we would also need the Wi-Fi. I already see that it's missing this shield here over the coil, sorry, this one here. Oh, and I can see now that the board is actually cracked. So if we enlarge it here, yeah, we can see a large crack like this. And if we turn it over, we can see the crack going here under this cap and this way, and also on the other way here. And that's not very good. It is really cracked there. Okay, let's have a look on ZXW and see if we have something on 14 Pro core. Okay, let me rotate the board like this. So we have a crack here. It's like here and coming all the way here. This is all ground. Okay, and if we let's see how many tracks we have in this area. Okay, so all these are compromised. Okay, so that's from the charging port connector. And this one goes to a chip right over here. And it goes to the CPU. And there's a lot. So all these are broken because our crack comes like this. There's another one that goes to the CPU. And another one here. This goes to the bottom. So this is just the first layer. The first layer. Let's select second layer. These are all broken. Third layer. This is also broken. This is going here. So we have a lot of tracks. Let me select everything. See how many. So we have a crack right here and all these tracks are gone. And I can see most of them go here on the CPU in this area here. I don't even want to, because all of these go to the CPU, I don't even want to apply power to the board. I'm afraid it's not gonna do very well for the CPU, although I'm definitely sure that somebody powered it, because I can see here this shield missing. So somebody tried something on it. Yeah, but that's bad. So an alternative, let's have a look at the bottom board. So I was saying that there's a weird greeny stuff here. I don't know what that is. Can it be some flux, green flux? Here you can see the broken interposer. Yeah, we can definitely see it here broken. And it's all broken this way. And the board also has a crack here. This part is lifted. Let's see if we can zoom in. Yeah, so you can see that the board is cracked here and the side is upwards, and this is somewhere in the middle of the rest of the board. So in theory we should move everything over to a donor board. I'm gonna focus first on the data. So if we can successfully move over the CPU, so we need from this board the CPU, we need the logic eprom, which is right here under this shield, we need the NAND, and I'm also gonna take over the Wi-Fi chip. Hope it's not damaged, so we can use it later on the new board. So first thing, we're gonna start to clean the underfill around these chips, lenght, Wi-Fi and CPU, and then we're gonna slowly remove every one of them and proceed. My god, there's so sunny. I'm gonna start with the underfill on the Wi-Fi and NAND. Actually, I'm gonna start with the NAND, and we'll go to the CPU afterwards when the board will be really hot. Let's see if it works with this holder. It's not very heavy. So I'm gonna set the hot air to 230, 30 air, and let's just start working on the underfill and on the sides of these ICs. I'm slowly heating up the board. As I said, I'm using 230. This here on this side is not very strong. I don't really care about the parts around the board because this board will not be used anymore. And I'm just gonna roughly clean it like that. This is a bit stronger. Here we have some ground resistors. They don't have any electrical use in this application. I don't know why they are placed there, because if this would have been a 1 terabyte phone, then the NAND will extend up to this shield over here, and those would be off. So those resistors are connected to ground. I don't know if it's for design or why they put them there, or it's something to do with the strongness of the board. Alright, so the camera froze. No problem, didn't lose anything. See, this is why I said this is a bit too light weight. and it doesn't stay properly. I need to hold, see, I'm holding it with my finger so it doesn't move. I'm being a bit brutal over here, but as I said, we don't really care about the board. Okay, let's do the Wi-Fi. Constantly looking to the screen to see if you can see properly what I'm doing here. Okay, so this is nasty and the board is not very well fixed here. Yeah, need another holder. This is too lightweight. Let's grab the WL one. Look the difference between them. Let's do it like this. This is way better, and this go is quite hard here. I'm only using 230 degrees, and that doesn't help either, but I don't want to put too much heat stress on these chips because I need them, and I don't need a board, so I can be a little rough. I think we're good here. Yeah, this is good. We can now proceed in removing these chips. Actually no, I'm gonna remove the CPU first of all. Let's go and do the same and clean the CPU part also, and then we're gonna get back to them. This is rough. Over here too. Let me set up the camera a bit better. I think this is good. Again, I'm still using the 230-30R. I still don't care about the parts surrounding the CPU. so they can fly away if they want to. Okay. Okay, let's take care of this part. Alright, so now we're good. Okay, time for the CPU removal. So let's have a look at it. This is how we see the CPU here, right? So we're gonna use this spray tool. It looks like this. It's very thin, but it's not that flexible. I have more flexible ones, as this one, for example. This is too soft, you see. So this is what I use to remove the CPU. Now if we look here, we have a main entry point around here in this area, but if we look on the schematic, yeah, let's rotate it as it stands before us. Okay, you see we have the CPU has below it some deep trench capacitors. They look like, let me change the camera. So they look like this, right? So you can see these little guys. Those are kind of glassy, so they are called deep trench capacitors. We need to be careful not to disturb them, otherwise we're gonna have high booked current. So we need to enter our blade around here like this, see? So we don't damage this one or this one. So ideally we should only enter like this. Alright, I'm gonna take away the microscope because I'm not gonna use it. I'm gonna use a very big nozzle. It looks like this. It's fairly the size of the CPU, right? And I'm gonna install the nozzle, and I'm gonna use 365 temp, 365 and 65 air. Alright, so now I just wanna be, sorry, this is the tool. I just wanna be here in position. I need to have a look. This would be great if I could do it under the microscope, but I can't because it's not gonna fit. But I'm gonna do it without the microscope. I say the microscope is would be nice because we can see better what's going on with the solder around the CPU area. Yeah, but let's start. This is real time. I'm gonna slowly hit the whole board. It's important not to rip any pads if they are not already ripped because of the cracked board, but I hope they are not. I can see the solder already melted around it, and I can see I can already insert my tool here, as I said. I'm not forcing it at all. Okay, and it freely came up by itself. Now the big question is, do we have any rip pads or not? Let's have a look at it. I'm gonna enlarge it. This is the best focus I can get, and I cannot really see ripped pads, which is nice. Yep, no rip pads. Cool. So I'm gonna take this CPU and place it aside. And now we can continue with the rest of the required chips. That means the NAND, the Wi-Fi, and the logic eprom will be last. Okay, for the NAND and Wi-Fi, I'm gonna switch the nozzle of the hot air. I'm gonna use an 8mm one. Let me show you. So it's like this, right? I'm gonna keep the 365 temp and air. 365 and 65. Okay, so with the big nozzle installed, we can start removing the ICs. I'm gonna start with, let me first check on ZXW if the number 1 pins are properly marked, because it's not the first time I can see in ZXW that they have the number 1 pin not really good marked, so this Wi-Fi should be like that, alright. And the NAND A1, yeah, it's correct. So the data is correct on ZXW. So we can just remove the chips now. Again, as I said, I'm gonna use 365 and then 8mm nozzle. Gonna slowly hit the board around. Apparently the Wi-Fi takes a lot of heat. Yeah, it's off. Okay, so Wi-Fi off. I'm gonna put it aside. And now let's take the NAND off. Board is already hot, so this should really work well. This has lots of grounds around it, so it will take some heat. It's not ready yet to come off. Alright. NAND is off. Perfect. Everything seems good. Now there's only one thing to do, and that's to remove the logic eprom. So the logic eprom, as I said, is under this shield. So this is the best I can do to zoom out. I'm gonna use a lot of heat here for 20 and 80 air, and I'm just gonna bump up this shield. Now the board really has no interest for us. Yep, shield is out. Here's our eprom. Made a mess here, but there's no problem. As I said, we don't care about anything around here. I'm gonna use here to remove the eprom. I'm gonna put some liquid rosin. Yeah, looks like this. You can prepare it yourself. And let me see, I have a board already prepared, a donor board. So I've cleaned this board, I've removed the Wi-Fi, the NAND, the logic eprom and the CPU. So the board is clean. I'm gonna set it here, and I'm gonna try to move over the logic eprom in one go. Let me just add some flux on the new board. And here I'm gonna put some of this liquid rosin, because this will allow the balls to remain intact, you know. I don't want to reball this chip. Board is hot. Alright, I'm gonna use 380 and 50 air for this one. And we'll take it out from here. Okay, it's out, and you see the pins there are just perfect, round. And I will move it over here to the new board. I need to rotate it so it suits my position here. So it's in place. It looks good. Let me clean the board a bit. I'm just gonna cool it off so I can apply some alcohol, IPA here. Alright, and it's perfect. Good. So we have the donor board over here. The original we don't need. So now it's time to prepare the chips. So I'm gonna install the NAND and Wi-Fi, and for that we will need to reball them. Let me see, does this one fit here? No. I think this is good. So we can see here the NAND sitting very nice. Let me put it this way so you can see it. So you can see the whole picture. Alright, I'm gonna use some flux. And then I'm gonna need some solder paste, I'm gonna use the 148 mechanic solder paste. I need to replace the tip on the iron. Yeah, and I'm gonna set the iron to 280 degrees. 280, so we're fine. Just clean the tip a bit. Get some paste on it. And I'm gonna try to replace all the solder on the NAND with the 148 one. Seems fine. And now I'm just gonna wake it off. Again with 280. I hope we can do it. It works fine. I'm not keeping the iron in one point, so I don't heat stress it. I lost it. Damn it. I think it's better now. I still have here a couple of points. Alright, so we're good. You can just clean it now with Q-tip and some IPA. It still has some remaining underfill on it, but we're gonna clean it. I'm gonna set the hot air to 230. 230 air. And I'm gonna get my favorite tool, this one. Yeah. Hit it slowly. Perfect. So we're good over here. I'm gonna use some cleaner microfiber cloth. I'm just gonna wipe it. Yeah, so we're done with the NAND. Looks good. I'm gonna handle the Wi-Fi chip also, and then we're gonna both reball them both. Let me firstly try to. I'm using the small things in the fixture because I don't want the chip to have a very good contact, so I don't lose heat, and thus I'm gonna need a very little amount of heat while working on it. Otherwise, the whatever is below it, we're gonna suck up the heat, and we're gonna need to use more heat. Again with the 148. I'm gonna replace the solder with the 148 one. This is good. And now we can just wake it off. I'm taking advantage of the chip being warm because 280 is a fairly low temp. Okay, it's all good. I'm gonna clean it again with a Q-tip, and then we're gonna use the microfiber cloth to give it the final clean. Perfect. Have the cloth here, it's soaked in IPA. Yeah. And the chip is perfect, ready to be reballed. Okay, don't even know, I think we should also clean the CPU and reball it afterwards, reball everything. Let me find a way how I could use this holder for this CPU. It doesn't work like that. Does it help if I put it like this? Okay, maybe. So we have the CPU here, and it's gonna be the same procedure. I'm gonna use first of all, I'm gonna replace the solder balls, the current solder with 148. I'm gonna need a lot of flux. Right, so we can go on using the iron again at 280. I'm gonna add a big blob of solder, but not 148, sorry. I need the 138 solder, and I'm gonna use some leaded one like this. Yeah, so I'm gonna add a big hefty blob. Alright, and I'm gonna start just wiggle it around all the pads. Here I need to replace the solder with this one, but not necessarily to replace, but even them out. I'm not touching the CPU with the iron, I'm just touching it with this blob over here, and I'm being very careful. See how the balls remain on the CPU? It means that the CPU is still not warm enough, but it's gonna get warm. The deep trench caps, I'm avoiding them so I don't upset them in any way. I think I need a fume extractor. I'm not using one, but lately the fumes are bothering me. Okay, so I think this is good enough. I think they are all even now. We're gonna do this later also, do the same exercise, but now I'm gonna clean it. I'm gonna first clean it with a swab. I don't like the swab because it leaves all those hairs. I have here a box with IPA, and I'm just gonna soak the CPU in this IPA, although it's not very clean. Let me clean the... well, it soaks there a bit. Let me clean this pad here. And I also want to clean the holder. So holder is relatively clean. Good. Now I'm gonna clean the CPU a bit. Gonna clean it on both sides. Now, let's blow. I'm gonna pour some IPA on it, clean IPA. Both sides. Perfect. I'm just gonna blow off the excess. All right. And now I'm gonna take the other clean holder. Okay. Let me make some room here. Okay, perfect. So I'm gonna take one of the tweezers. Let me see which one is this one. That is a bit blunt. And I'm gonna set the hot air to 170 degrees. 170 and 30 air. And I'm just gonna slowly heat up the CPU. And we'll start to slowly remove the underfill. I'm not forcing it at all, and it's not ready yet to come off. The CPU still needs to heat up. Yeah. So now we're getting somewhere. And we need to take our time and our patience and remove everything here. Remember, we're not pressing at all on the CPU. We're just gently moving the tweezers around. This is why I use 183 solder, so it doesn't melt. I don't want it to melt. I want the balls to remain intact. I think we're good over here. let's clean up this area. Okay. Let's see if there's something on the sides. Good. Okay. This is the worst area of them all. It's a bit difficult, so you need really to focus here and not force anything. Just gently move it around until it slips over. Remember, all the CPU is getting now is a maximum 170 degrees centigrade, so that's really low. It will not harm it. Okay, and we still have one part to go. Here up. I don't want the CPU being wicked, so I want it to have nice even balls when I reball it. So when it goes into the holder stencil for reball, I want it to have already the balls there. And then the 183 solder I'm gonna use to reball it will just fuse with the already existing balls that are again 183 leaded solder. Okay, so I think it looks fairly good. still has a few tiny bits of underfill around some of the pads, but it's not a problem. Yeah, so it looks nice, as you can see. I'm gonna use some pig hair brush. It's made by Mechanic. It's a bit rough, so it's gonna remove any tiny particles out of there. Yeah, so I think we're good. I just need to clean a bit the pad that I'm working on. I have a problem with the tools to be cleaned. I always want them clean and nice. You know, you just work if everything is cleaned and arranged and you have all the tools at hand, then you just work easier. That's it. I'm gonna put some paper tissue here. The problem with this pad, so this is a very good pad, but it's not really insulating as it's transmitting heat. It absorbs a lot of heat. In the past I was using this type of pad. This was very thick and you can see it has a lot of air inside it, so it's very soft. It's like a sponge, you know, and it didn't absorb the heat. You can just place the chip there and work on it with low temps. If I do this on this one, this will suck all the heat and I need to use more temp. So to avoid adding more temp to the parts, I'm just using a tissue. So a paper tissue. I'm gonna put the CPU here, and now we're gonna put some flux on it, and we're gonna come again with a solder ball with 183 leaded solder and go over it one more time. Yeah, then we'll clean it again in lots of IPA, and once it's clean, then it's ready to be reballed. So again, I'm gonna add a big blob of solder on my iron. The iron is again set to 280 degrees, and I will just slowly come over all the balls. It takes some time because the heat on the iron is only 280. It takes some time for the CPU to get up to the temp, but that's alright, no problem. I'm just going on the outsides because it heats faster. It takes more heat on the inside. And now we'll go over these ones. I'm very careful not to disturb the big deep trench caps here. We're gonna know when we're gonna boot the board. If there's a problem with them, the board will boot with very high current, like 300 milliamps instead of 80, you know, or more, even more. Yeah, I think all the pads are now even. They look really, really good. And I think we're done with it. We just need to clean it, and then we can just reball it. So again, I'm gonna put it in my IPA butt. I need to replace this IPA. 1 second. I'm gonna go and throw away what's in that. Be right back. Okay, so now that is clean. I can add some fresh IPA. Let me also clean the lid. Yeah, good. This is the IPA I use. Sorry. How can I put it so you can see it? IPA 99 cleaner. It's the best one of the ones that I've tried. Some of them leave stains, others don't evaporate like I like. I don't know, this is the best one that it fits my needs. Okay, and now I'm gonna clean it again with a brush. And we'll make sure we're gonna remove all the flux of it. I'm gonna do both sides. So I think we're fine. Now I will just pour some more IPA, clean one, on it. Yeah. And now I will just blow it with the pump. You see? How can I show you like that? Just gonna make sure it's clean. Okay, so now I think it's perfect. Let's see how it looks under the microscope. See? It looks very well. And it's ready to be reballed. There's no dirt on it. And the balls are quite nice and even. Okay, but first let me grab the stencils, because we're gonna start with the NAND and the Wi-Fi chip, and then we're gonna proceed. The last one will be the CPU. Let me find the stencil for the 14 series. iPhone 13, iPhone 11, iPhone 14. There's a stencil for 14. Alright. Next thing we need to do is prepare some solder paste. The solder, I like it very dry when I reball chips. I'm gonna put the CPU aside now, because we're gonna do the NAND and the Wi-Fi as I said. Put this aside too. Alright, so now I'm gonna set the hot air to 330 and 30 air. I'm gonna grab another tissue. Alright. And I'm gonna take a hefty amount of 183. You can see it now, you see it, 183 solder paste. This is a bit too much, but it's okay. And we'll place it here on this tissue. Perfect. And now I'm gonna blow some hot air on it. It's the same tape I use for reball. Until I can see the flux is slowly coming out of it. Yeah, so now it's really shiny. I'm gonna do this. I'm pressing it extremely hard. And then I'm gonna do this again. Okay. So now it is dry enough for me to do the reballs. Going back to the microscope. Okay, I'm gonna get the tissue. As I said, I'm gonna use a paper tissue, so the heat from the chip will not transfer to the pad. And I'm gonna start with the Wi-Fi chip. So Wi-Fi here. We're all good, you can see it. Let me see where's the Wi-Fi on this stencil. I think it's this one. This stencil is not very clean. Let's see. Is it clean enough? No, it's not. Let me clean the stencil first. This is annoying. It has bits and pieces of hair on it. Just using the brush and IPA. And now the microfiber cloth just to wipe it off, give it some air. Alright, let's see now. Where are we with it? I think we're good. We're good here. Can you see it properly? Yes. We're gonna take some paste and apply the paste over the holes. I'm not being very gentle, I'm actually pressing it a bit. There's no problem with applying a tiny bit of pressure. It's okay. Alright, so I think we're good. We're ready to reball it. Let me get my reballing tweezers, which are wearing out. Okay, so again I'm on 330 air and 330 temp, degrees centigrade and 30 air. Sorry, I'm a bit tired today, I don't know. It's a bit difficult to speak while working, but I'm doing this for you. And I'm just moving it around so the stencil doesn't warp. Alright, so we have nice balls. We're good. It's removed from the stencil. There's a couple of balls here that flew off the stencil. We don't need those. I'm gonna add some flux on it, and I'm gonna reflow it again, and then we're gonna stick it to the board directly. While it's still a bit warm. Alright, so it has been reflowed. Let me get the board. Where did I put the board? This is the board. Alright. And let's see what was the orientation. So first of all I'm gonna set the hot air to 350 degrees and 40 air. And let me see where is pin number 1. On the lower left. Okay, I'm gonna add a tiny amount of, I think it's a bit too much, of flux. Okay, lower left is like this. I think it's pretty much in position. and I'm gonna come with 350/40R. I don't like the way it sits. Don't understand why it goes where I don't want it to go. It a bit lower. Okay, so I think this is good. Again, 350/40R. I'm with a 9mm nozzle. And we'll allow it to float in place. The board was not warm, so it might take a while. Yeah, and the chip jumps if I move it, so it's fine. Remember, when you reflow or when you heat up a board, it will always take a lot of heat here around the shields or around the large chip. If you have the CPU or a NAND, it's gonna take more heat, so you need to be careful with the air you apply and where you apply it and how you apply it. Okay, we move to the NAND. We can start reballing this one. This is good, but I have some debris here that I don't really like. Let me remove it. Good. Now I think we're okay. You can't see it. I need to take it a bit lower, like that. You can see some dirt over there. And over there, let me blow some air on it. We're good. Let's apply the solder. This will, the NAND will take more heat than the Wi-Fi chip because it's heftier. Okay, I'm just looking to see if it's evenly spread out, but it looks good. Okay, perfect. I'm gonna set my reballing tweezers. Okay, set the hot air to 330/30R and just wiggle it around. And it looks good, almost perfect. Okay. Good. And I'm gonna reflow it again. Gently. Perfect, so the balls are nice and even. I'm gonna set the hotter now to 350/40R. We get a board, and let's see which was pin number 1. Pin number 1 is lower right. Lower right, yes. I'm gonna add some flux around here. I think it's a bit too much, because there's already flux on the NAND itself. Okay, so I said the lower right is gonna be like this. Again, we're gonna come with 350/40R. We need to be a bit patient. Let me rotate it like this so you can see the better picture. We need to be patient with it because the NAND is quite hefty and will absorb a lot of heat. So I need to get the initial position. I think we're good. So 350/40R. I'm currently pressing a bit of it on it, and now I have released it. I'm gonna blow it in the middle because the heat will extend on the sides. It's not good. Okay, so the balls are intact. The problem is that I have used too much flux, and it just bubbled. No problem. Luckily the balls didn't melt yet, so we don't have to reball it. Just gonna do it again. Should have had more patience with it. It's way too much flux on the board. Yeah, so it is bouncing, meaning that it's stuck right there. Okay, so in this moment we have installed the NAND, we have installed the logic eprom, which is here, and we have installed the Wi-Fi chip. So now we only need the CPU installed. What I want to know is that I'm curious if maybe we have a short or something after installing the NAND or the Wi-Fi. So I'm gonna cool off the board, and I'm gonna try to power it on and see if there's any kind of short. In theory we should have no consumption at all, but I need it to be really cool. I'm still using the hand pump to cool it off. I think we're good. Alright, so let's see now. Let's apply the power. Let me also put it on the screen so you can see what's going on. Yeah, you can see the power supply there. Let me find the 14 squid. So 14 is in place. I'm gonna press the power, and we have no consumption at all. If I prompt it to boot, it should do nothing without the CPU. Yeah, perfect. So we have nothing there. No sign of anything. So we're good. I hope that clears up any kind of a short that we might have. Alright. Now we can proceed with the installation of the CPU. So for that, first of all, I'm gonna prepare the board, and I'm gonna place it here in this holder. I want it quite straight. Alright. Alright, perfect. I'm gonna heat up the board just a tiny bit so I can add a tiny amount of flux. Okay, not too much. Just so we can get... I don't want too much flux here. Like this. I spread it with my finger. It's good, because we're gonna have a ton of flux on the CPU itself. I'm gonna put this aside. Alright, and now I'm gonna take the jig that I use for reballing the CPUs, and it's this Mijing Z21. It's a very good tool, saves me a lot of work when reballing CPUs. Okay, let's grab the CPU if we can. 16, I'm not sure about the orientation. Let me find the stencil. 15, 16. So here's the 16. Typical. It's very magnetic and it just flew off my hand. No problem. So I need the CPU like this, in this orientation here. This is a very good tool. I really love it. Okay, and now you can see it right here. I'm gonna... I blew too much. Just wanna make sure there's no debris there. Having a second look. Can see something here that I don't really like. Okay, it's off. Can see something here. Here. Okay, we're good. So if we're gonna get a high boot current, then we're gonna have to remove these caps, which I don't really like, but there's nothing else we can do about it. So the stencil is fine. Let me grab my tool. I'm using a different tool here because this is very magnetic and this tool is not that magnetic. I'm using this one compared to the other that I use to usually reball chips. And I'm just gonna add the paste, which is extremely dry. That's how I like it. This is a very big, hefty CPU, the A16. It requires a lot of heat. So all the trick here in reballing CPUs or swapping CPUs is actually your technique and is about the amount of heat you need for desoldering or reballing. Just think about it. For example, now we're using 183 paste, right? So in theory we should be able to come with 200 degrees and just melt it. Well, it works like that if the paste is on a piece of paper, but the paste is actually on the CPU. So it's not the balls that need to form to melt first, but it's the CPU that needs to take all that heat and send it further to the balls to make contact, you know. And the larger and the heftier the piece you work on is, the more heat you need. If you apply too much heat, you damage it. If you apply too low heat, you're gonna need a lot of time, and again you're gonna damage it because you're gonna cook it. And there's a circle there. So again, I'm doing 330-30R. This will gonna take a while because, as I said, it's big. Let me put it somehow so you can see it better. It's way easier when I do this and I don't record. I don't see it very clearly. So now it's better for me. I hope it's good for you too. Alright, so let's go. 330-30R, we're gonna grow old here because the CPU is big. The holder is quite hefty also and sucks up the heat. The stencil is not so big, it's not as big as a stencil that has all the parts for a model. But we're gonna go around like this, round and round and round, until we see the first balls form. We're gonna see them on the left side. So in theory they should appear there. Although this tool for reballing is magnetic, it has a very strong magnet that keeps the stencil in place. The stencil will still warp if you don't do this properly and move it around. And that's why I'm also holding it with the tweezers. I could hear the stencil going off on the upper right side. That means it's warping a bit. I don't like the thing that it's on a very left here, so you can see it properly on the image. It's not centered for me, and it's a bit weird that I'm used to it. And this just takes a while. You need to be patient. Don't do anything, just rotate it until you can see the first balls forming, and then you just follow the path they wanna go. I'm gonna evenly form the balls from left to right, because I'm gonna need to move the tweezers in the direction the balls will form. You see, they started to form. I will just come like this, move the heat up and down so it doesn't doesn't get colder in different parts. Okay, and I hope that all the balls are sticking to the CPU. No, I have at least one that remained in the stencil, but it's only one. Yeah, the rest of them are fine. So I have this one here, the second one on the top, and I think that's a ground. But I'm just taking it and I'm gonna place it over here. Okay, let's fix this also, although I don't think it's needed. I think it's a ground, but better be safe than sorry. If we still had a ball, just put it there and come again with the same 330-30R. Is there some dirt here? Okay, so the ball is now in place. Hope you saw something. Okay, now before of everything, my tools are extremely important, so before doing anything else, I'm gonna take this one, as it's still warm, I'm gonna warm it a tiny bit again, and I'm gonna clean it extremely well. And the IPA bath. Get a brush. This is one of the most important tools I have. I need them clean every time. Any tiny amount of speck of dirt can easily mess up with your reball. So I feel it's clean enough now. I'm gonna use the clean microfiber cloth. Okay, have another look at it. Looks good and clean. Perfect. Put the tools back. Clean it with a bit of IPA. What's it? Right, so now I've cleaned my tool. I'm gonna place it back in the drawer, and I'm gonna have a cigarette break, and then we'll continue. I'm gonna come back and continue with the CPU. I'm gonna pause the video for now and resume in a bit. Alright, so we're at the final part. We're gonna handle the CPU now. Let me get rid of this mess here. And let's see. Alright, I'm gonna apply a hefty amount of flux all over the CPU. I want a lot, I want it to boil in it. Okay, we're gonna set the hot air to 330 degrees centigrade and 30 air. And you can notice that I'm actually holding the CPU a bit up, so it's not sticking to the tissue either. And I'm gonna slowly heat it up, so the flux will go all over it. The excess will flow on the tissue, and we'll do it until we can see the balls forming and reflowing. Okay, I have a problem. It's right here on this corner. I have two balls that united, and I don't like that. Let's see if we can split them apart evenly. No, that's not good. Okay, no problem. Let's see on the schematic what those two pads are. If they are ground, I really don't care about them. Let me look. So it's the first two. Actually, we have a corner with no ball. How is this orientated? Like this is up. Okay. And these two are here. Up here, both of them are grounds. I don't care about them. I'm just gonna remove this ball from here. Okay. Both grounds. We don't care. We take it off. And now, let's bring the board over here. Can you see it properly? You can, right? Okay, and now the CPU is here. It's gonna come like this. It's gonna come like this. Okay, I'm not gonna use the big nozzle, the big one that I used to remove the CPU. I'm gonna use the 8mm nozzle that's on the machine now. I'm just gonna cover with a piece of copper. I'm gonna cover the PMIC because I don't wanna get it hot. I'm gonna use 350 and 60 air. Maybe it's a bit too much, the air, but this will gonna take a lot of heat because the CPU is quite large. A16 is, I think, the largest one of them all. I just need to hold it in place for a few seconds, but I'm having trouble centering it. It's just like, I don't know why it's too difficult to do it. So difficult. It's like the pads on the board are not really straight. Okay, this is annoying, and the position I have here so that you can see it is not something that I'm used to. But that's life. I'm gonna use all the time in the world just to make sure it's sitting right. I'm sorry I'm wasting your time with it, but I want a perfect solder here, and I really don't want to reball it again. I think we're good. Move the tiny bit. And let's see. I saw it shifting. Okay. It shifted a bit. We're not there yet. When I feel we're there, I'm gonna bump it just a tiny bit. Yeah, so it bumps. I think we're fine. I think we are good. It took a bit longer than I liked it, but that's life. Looks good. I'm gonna use the hand pump just to cool it off. It wasn't extremely well centered because I saw it shifting a bit when the balls have melted, but I hope it's gonna be fine. Let's see if we can take it from the holder. Yeah, so the balls are looking really nice here. I don't know if you can see it. Yeah, so that is really not bad. This side is good. Here we can't see anything because of the parts. But let's hope for the best. I'm just gonna cool it off. Slightly more. A tad more. And now the big moment of truth. Let's try to power it on. Let me bring the power supply on screen so you can see it, and let's see how is it behaving. We should have a full boot now if all goes well, but it can go wrong because any of these parts that we've moved are defective, or it can go wrong because the board wasn't prepared and was damaged during the preparation, which is quite complicated. I don't get it well on the first time. So prompting to boot, nothing. I always forget the 13 Pro, which is the proper. This is I'm not extremely happy with it. This is not a good behavior. Let's try again. Okay, so it seems to be doing something. I don't like how it starts at 100 and something, but this looks like a boot. Yeah, let's try to connect the screen. Have a screen here and see if we get something, if we get any image. Okay, power on again. And we have an Apple logo. And we have picture. That's good. The consumption is still high. And I have no touch. No touch is bad. Okay, let's see, maybe there's something wrong with the connector. Connector looks good. I'll press it again. And let's prompt to boot again. I didn't prompt it to boot properly. I'm not doing this right. Definitely not making a good contact here. Okay, so something is not right. And what could be the problem? Am I not doing this properly? It's very difficult because the flex, okay, it's booting now. The flex of the screen is right there. Okay, so definitely we have no touch. I'm just gonna leave it a bit, and I wanna see where the current will go on idle. It is a bit high. It will reboot every 3 minutes because it doesn't have the proximity flex. But I don't know why we don't have touch. It could be also the screen is not good. I'm not very sure if the screen is okay. And I don't really like it staying at around 0.3, 0.4 amps idling. Yeah, so this is weird. No touch. Okay, let's check the display connector, and let's see if we have all the values there. If we have the values, I could also suspect the display might have a problem. There's a piece of dirt here. There was like a piece of dirt in the connector. Let me see the screen connector. How does it look like? Okay, so the connector looks good. This is gonna be difficult. Okay, let's see the diode mode readings on the connector. Let me rotate this like that, and we have the connector right here. You can't see it all, right? Can you see anything there? Yeah, I'm gonna keep it like this, and whatever you will see, we'll see. And let me see if I put this here. right? Okay. Actually, I think it's better if you see the microscope. Yeah, like that. Perfect. And let's check here. I'm gonna have the red probe on the ground, and we're gonna start with the pins. So we should have on the bottom side 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 readings on the bottom, then the ground. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I don't have anything on 13. 14 is good. Then we have a ground. Then we have a couple of OLs, 2 OLs, a ground, another 2 OLs, a ground, 2, 8, 1, 1, 2, ground and OL. Okay, so 13 is not good. Okay, let's do it again just to be sure. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 is OL. And 13 here on the schematic. 13 on the schematic should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13. This one should be 0.3. Let's see where it goes. It goes to a resistor near the CPU, and that's a resistor that I've had problems with and I have replaced when I prepare the board. So it's 1, 2, 3, 4, 5, 6, 7, 8 resistor. As you can see it here. This might be our problem. Okay, let me make some room here. I know for sure that I have replaced that one because I lost it when I prepared the board. So it's 1, 2, 3, 4, 5, 6, 7, 8. 8. The 8 part, like you see here, 1, 2, 3, 4, 5, 6, 7, 8. Oh la 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 la, I'm missing it completely. So 8 is missing. That's not good. Let me find the original board. Let's see if we have it here. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so we have the resistor here. Let's remove it fast. 1, 2, 3, 4, 5, 6, 7, 8. I was a bit confused. I don't know why I didn't install it in the first place. I thought it's a ground resistor, but apparently it's not. It's 380. Okay, I have grabbed it. Let me put it here on the side for just a second. So I need 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. The problem is that I'm gonna hit the CPU now. Where is it? I took the resistor. The resistor with the flux range. Okay, let's see how we can do it without upsetting something here. I need low air. 1, 2, 3, 4, 5, 6, 7. This is extremely annoying. Come on, just stick there. I think we're good. Oh, la, 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 la. Okay, let's see again if we can boot the phone and have working touch. Can you see? Yeah, you can see it now. Let's put the power connector here. Okay. Let's put the screen right here. Okay, bring the power and let me see how I can prompt it to boot without damaging anything here. All right. Looking good. We have image and we have touch. So this is a breakthrough. This means that we have access to the data. So now we need to stick the board to a bottom board that is in good condition, and we can copy over the data. It looks very good. I don't really like the power consumption for now, but it might be a bit upset because it doesn't have the bottom board and it's still querying stuff that it cannot find. So it might keep the processor, the CPU busy. It's not a very good idle current, but we can investigate this further. The most important thing is the data. So in the part 2 of the video, which I'm gonna do later, I'm gonna prepare the bottom board for this one. So for now, I hope this helped you, and I hope everything is good and you'll enjoy the video. Thank you, and we'll see you in part 2. When we're gonna repair the bottom board and work it further. Bye.